All right. For those whom I haven't met yet, my name is Jonathan Munemo, and so I'm going to be talking about competition and innovation behavior of firms in sub-Saharan Africa. So this is joint work that I'm doing with a colleague of mine, Eugene, who recently joined the ADB. Okay, so here's an outline of the presentation. I'll first of all introduce the topic and give the overall context of what we're trying to do here. Then I'm going to talk about, the theory, the empirical literature, and then provide the contribution that we make. After that, I'll move on to talk about the data and the empirical specification, then talk about the results, and then summary and implications, and then the future research. Okay, so it is widely recognized that technological innovation plays a crucial role in the development process by promoting economic and productivity growth. And by technological innovation here, I'm talking about the creation or introduction of new and improved products or production processes, okay? So this is widely, recognized. And therefore, it is not too surprising that there has been a great interest in trying to understand, the factors that impact innovation, especially by policymakers in developing countries. And in particular, the effect of product market competition on innovation has attracted a lot of attention. So a useful starting point, therefore, is to kind of look at the theoretical predictions on the relations between competition and innovation. And here we've got three main views. So the first, what I call the traditional view, which has long been held to be true by many economists, is that competition is very good for the economy, right? Because what it does is that it raises incentives for production efficiency, and this actually motivates firms to innovate. So basically, if you look at Aaron 1962, Gilbert and Newberry 1982, they discuss this traditional view. Then there is the Schubert Aaron view, which says that in fact, higher competition is bad for the economy. Because then what happens is that it reduces the rents from innovation and makes it very hard, for a firm to appropriate the returns, from R&D investment, in the absence of monopoly power. And hence, greater competition, is a disincentive for firms to innovate. And this view is discussed, for example, if you look at Salop 1997, Dixon Stiglitz 1997, Roman 1990, Gion and Horwitz 1992, and other studies as well. A third view that has emerged in the literature more recently is by Gion and Associates in 2005. So basically, they argue that the impact of competition on innovation depends on how far a firm is from the technological frontier. Okay, so basically they say that for firms that are much closer to the technological frontier, greater competition reduces their pre-innovation rents. So pre-innovation rents are the rents that they get if they do nothing, right? So when this goes down, this actually motivates these firms to innovate, because if you think about it, they are so close to the technological frontier, and so basically it doesn't cost them a lot of money to innovate. And hence, for these firms, innovation becomes a means of escaping competition to maintain or increase their post-innovation rents. However, if you look at firms that are further away from the technological frontier, higher competition basically discourages these firms to innovate, right? Because they are so further behind, and it is very costly for them to innovate and catch up with those firms that are close to the frontier. And so they are discouraged, and essentially, basically, you have this Schubert Aaron effect dominating, and as a result, you have a decrease in innovation. Okay, so also interestingly, Arjun and Theo basically develop a model, in which when the competition is low, the proportion of efficient firms, what they refer to as neck-and-neck competing firms, is larger. Then the escape competition effect dominates the Schubert Aaron effect. And then in their model, they also show that when competition is high, there tends to be a larger proportion of the laggard firms with low profits, and the Schubert Aaron effect is most likely to dominate in this case. So this therefore implies that the relation between innovation and competition is nonlinear, right? So if we were to look at it visually, it looks like this. It's an inverted U curve, right? So this is actually saying that competition is a diminishing effect on innovation, according to the model that they developed. So now let's look at what the empirical literature has to say about all this. Okay, so if you look at the earlier studies following Schubert in 1943, they did find a negative relationship. But then the subsequent literature in the 60s and 70s found an inverted U relationship, Scherer, Kamian, and Schwartz, for example. Then after that, in the 1990s, studies started finding a positive relationship. So if you look at Gerosky, for example, Nickel, and other studies. And then in recent years, attention has focused more on the nonlinear relationship. And so in their influential paper, Aaron et al. 2005, they find strong evidence of an inverted U effect of competition on innovation using a panel data for a sample of firms listed on the London Stock Exchange. However, studies focusing on transition economies by Kalin et al., as well as a recent study on publicly traded firms in the United States by Hashmi 2013, do not find support for the inverted U hypothesis. So to me, this is saying that the evidence empirically is mixed, right? We have mixed evidence here. So basically, our contribution is to exploit a comparative panel survey of more than 1,000 firms in 4 manufacturing industries. These are textile and garment, food and beverage, metals and machinery, wood and furniture, right? And to use this data to study the nature of the relationship between product market competition and innovation in Ghana, Kenya, and Tanzania. To our knowledge, the empirical links between product market competition and innovation in sub-Saharan Africa have not been studied before. So here's a quick overview of the data that we use. So the primary data set is based, like I said, on a comparative panel survey of firms. It is coming from the Center for the Study of African Economies at Oxford University. So with data between 1991 and 2003, and so for each country and year, the data identifies each firm, the manufacturing sector in which the firm operates, its output per worker, employment, materials, capital, and other inputs per worker, as well as other firm characteristics that are useful for our study. So basically, we take all these variables, the inputs and other cells and other variables, and deflate them so everything is measured in real terms. So this table just summarizes the number of unique firms by country and industry. Okay, so now let me talk about how we measure innovation, because there are several approaches that are used in the literature. So basically, our measure of innovation is based on the technology gap. Now, the technology gap measures how far a firm's technology is from that of the international frontier. And here, basically, we follow closely the methodology of Blalock and Gettler in 2009. So they compute the technology gap by subtracting the mean total factor productivity of firm I in sector C from the median total factor productivity of a firm, of firms with foreign ownership in the same sector, and then divide by the mean total factor productivity of firms with foreign ownership. So essentially, foreign-owned firms are presumed to possess much more superior technology, and so this distance basically, of a firm's total factor productivity from the median firm with foreign ownership is a measure of the technology gap. And so essentially what it tells us is that if it is positive, basically it's telling us that basically the firm is basically got there's a technology gap that is above industry standards, and if it is negative, it means in fact that the technology gap is below industry standard. It is much more innovating. So the smaller the gap, the better, the higher the innovation, based on how we measure this. And so essentially, total factor productivity is calculated, from a production function that we estimate using the Levinson-Perrin method, which corrects for the input selection bias that you get if we were to use OLS. For the sake of time, I'm not going to talk much about the first stage estimations. If anybody is interested, I'll be more than happy to share with them the results for the first stage, results. So in the literature, you also see that there are other measures of innovation that are used, such as R&D, expenditure, and patenting activity. But unfortunately, we couldn't use these measures in our study because they are not available in the data set that we use. Okay, so let me turn now to product market competition and how we measure it. Here, we closely follow the approach used by GeoNet 2005. So the starting point is to calculate the Lerner index, which is simply the ratio of a firm's operating profit divided by its sales, okay? And then take this Lerner index basically to find, a measure of product market competition, which is given by 1 minus the average of the Lerner index in that industry. So basically, this measure is at the industry level, right? And it assumes a value of 1 if there's perfect competition, and the lower values denote, greater market power or less competition. But for robustness, we also use a second measure of product market competition, which is simply the Herfindahl index, which, as you know, is simply the sum of the market shares squared for firms within an industry. Okay, so let me move on to my benchmark, the benchmark specification that we use in this paper. So like I said, our measure of innovation is this technology gap, right, of firm I at time t in country J. And so our key explanatory variable here is this product market competition, right? So we include the level term as well as the squared term because we want to test for non-linearities. Because as we know from Argion, the relationship can be nonlinear as well. Also, but to measure this relationship more precisely, we include a series of industry fixed effects, this lambda C. We also include country fixed effects measured by this term here. Time fixed effects are measured by this term here. So as a first pass at looking at the data, we can look at some scatter plots, right? To see if there's some kind of linear relationship between competition and innovation. So using the Lerner-based measure of competition, it's hard to see if there's any relationship, right? It's hard to see if this supports the Schubert Aaron view or the escape competition view. It's not very clear, okay? And then we also tried the same thing with the Herfindahl index versus innovation. Again, not much really can be discerned from this scatter plot, either in favor of the Schubert Aaron view or the escape competition view. However, when we fit a quadratic curve to the data, we get this inverted U-shape, right? Which basically shows that over the range, when competition is low, the technology gap is higher, right? Implying that, in fact, there's less innovation. But then, when competition is very high, right, the other side, you see that the technology gap is much lower, innovation is greater, okay? And we get the same sort of inverted U-shape when we use the Herfindahl index as well. Okay, so I'm going to discuss the benchmark results and the robustness results. I think, for the sake of time, I won't go over those. So essentially, we have different specifications here. So column 2 is basically proved OLS. Column 3, we include, industry fixed effects. Column 4, we put time fixed effects. Then column 5, we put the full set of fixed effects, industry, country, and time. So as you can see here, the linear effect of competition, right, is positive and significant throughout, across all the specifications. And then the quadratic term, the coefficient, is uniformly negative and highly significant across all the specifications, right? So this is telling us that, when competition is low, basically it discourages innovation in a significant way. But at higher levels of competition, right, there's a significant innovation activity taking place, right? And so basically, so there's evidence of this nonlinear effect that was sort of discussed by Agion and associates. So here I'm using the learner index, which is our main measure of competition. The results, using the HI for robustness, let me just keep those. They are broadly similar, and so I'll just keep those. Yeah, but one concern that we really have here is that competition is potentially endogenous, right? Because if you really think about it, innovation, some firms could use innovation to basically gain monopoly power over other firms. And so, with this problem here, and if this is true, then our results, are potentially biased. And so the way we address this potential endogeneity issue from reverse causality is to use 3-period lags for competition. And as you can see from the results, they are consistent with the benchmark results. The linear effect remains positive, highly significant. The quadratic effect, negative and highly significant. So nothing has changed, even when you try to minimize any possible endogeneity. And so this sort of, lends robustness to the benchmark results that we have. Okay, and so basically let me summarize and give the implications of this paper. So essentially consistent with the theoretical and empirical work by Agion, we find evidence that the relationship between product market competition and innovation is nonlinear and displays an inverted U-shape, which is robust over several different specifications. However, as cautioned by Agion and associates, the level of competition that corresponds to the turning point of the inverted U-curve should be treated with caution, since the relationship between competition and innovation is dynamic and evolves over time. So we shouldn't put too much weight. We shouldn't think about, for example, what is the optimal sort of level of competition. So we use the learner index to calculate an indicator of product market competition, which varies between 0 and 1, with higher values indicating greater market competition. So we know from our results that when competition is high, the escape competition effect is most likely to dominate. So this is interesting from a policy perspective if you think about it, because this implies that competition enhancing measures that are emphasized by the global engagement literature, such as importing, exporting, and the entry of foreign firms, and Lederman summarizes this literature, that these measures will foster more product innovation by incumbent firms in the sample countries. Also, the results imply that other policies, such as reforms in regulatory barriers to entry, to increase the entry rate of domestic firms, may also increase market competition, as Klepper and others have shown. But also, more importantly, they can also have a positive impact on innovation for the countries in our sample. So I think the bottom line here is that understanding that the relationship between innovation and competition is not necessarily monotonic, right, is crucial from a policy standpoint, right? That at any given time, basically, the policies that that have to put in place should take into account that, the relationship is not necessarily monotonic. And so one weakness of this paper is that we only have one measure of innovation. It would be nice for robustness to have other measures of innovation. And so I was looking at the enterprise surveys that are done by the World Bank. And there's a heading there, a topic H, which is interesting questions, that can sort of, push this research on innovation. So I'll just read to you 3 of the questions. So under H1, the question is, during the last 3 years, has this establishment introduced new or significantly improved products or services? Then H3, the question is, during the last 3 years, has this establishment introduced any new or significantly improved methods of manufacturing products or offering services? Then H7, the question is, during the last 3 years, did the establishment spend on formal research and development activities, either in-house or contracted with other companies? So these are measures, right, that we can use, to say something about innovation. And I think the next step basically in our study is now to switch to these enterprise surveys which have this data, because the Oxford data set unfortunately doesn't have these other measures of innovation. So thank you so much for attending my presentation. This is preliminary, so I look forward to your feedback. You know, if you think of something later on, you know, feel free to email me. My email is gxmunemo@salisbury.edu. Thank you very much.